Okay, guys, so now we're going to look at the applications of quadratics, and we've been given a problem. A ball is thrown vertically upward. After t seconds, its height, h, in feet, is given by the function h is equal to the following. What is the height from which the ball is thrown initially? So, when you're doing these guys, um, there's almost like a little progression chart that you want to follow, but it's helpful. First strategy should be to draw a picture. That's usually helpful. And then read what they're asking for, what problem hopes to solve or answer, and then decide the best method of doing this. And then obviously conduct that. So, let's look at this. First, so we have a ball is thrown vertically upward. Let's draw a picture. So we've got this person, and they're throwing this ball. We don't know how high or how far it goes yet, but eventually it's going to eventually come down and hit the ground here somewhere. And so if we look at this, it says after t seconds, its height h in feet is given by this formula. It says, what is the height at which the ball is thrown initially? So what does that mean? The initial height is when no time has passed since the ball has been thrown, so that means that t is equal to 0. That's what they're trying to tell us with that. So if we plug t is equal to 0 into that equation, h is equal to negative 16t squared, 96t plus 6, which means that h is equal to negative 16 times 0 squared, 96 times 0 plus 6, which means h is equal to 6. So 6 feet. Oops, I drew two F's. That's weird. The ball was thrown at 6 feet. Okay. So next, it says, how long does it take the ball to reach its highest point, which would be somewhere up here in the middle? Well, that highest point, we have a special name for it. It's called the vertex. And it says how long. Well, remember, this is a function in terms of t and h. This is the time. This is, x is the time variable. H is the y variable. So, at what time was the vertex at its highest point? How can we figure out the vertex? We have negative 16t squared a plus 6. Well, we have that formula that says x is equal to negative b over 2a. To get the x variable, well, x is actually t in this case. T is equal to negative b over 2a. And this is equal to h. And so, in this case, t is equal to negative 96 over 2 times negative 16, which is t is equal to negative 96 over negative 32, which is 3 seconds. The ball took 3 seconds to reach its maximum height. Pretty straightforward, I think. You just have to know which formula you're using and when. Okay, there's that one. So then what is the maximum height that the ball will go? Well, we know the time at which it reaches its maximum height is 3 seconds. So if we want to find the maximum height, we're going to go and plug that in. We have negative 16, 3 squared, 96 times 3, 6 is equal to h. This is going to be negative 16 times 9 plus 96 times 3. 6. Negative 16 times 9 is negative 144. 96 times 3, I think it's 248. No, 288. Okay. And so this is 144 plus 6, 150 feet. The highest, oops, that's not good. The highest height the ball reaches is 150 feet. Okay. So there's that one. When will the ball hit the ground? So what does that mean? Do we know what time that will be? Why? That's what they're asking. They're asking when will the ball? So that's a time. What time will the ball hit the ground? Well, then if it hits the ground, the height of the ball is 0. So what we're going to do is we're going to set this equal to 0 in this case. So we have negative 16 t squared plus 96t plus 6 is equal to 0. And we can solve this several ways. We can do quadratic formula. We can do factoring and things like that. I'm going to factor first. I'm going to factor out a 2 because I believe 2 goes into every one of these. Negative 8t squared plus 96 divided by 2 is 48. No. Yes, 48. 3 is equal to 0. Okay. Divide by 2. We have negative 8t squared plus 48t plus 3 is equal to 0. Multiplies negative 24, adds up to 48. That's not going to work. Factoring will not work for this. So let's use quadratic. We have x is equal to negative 48 plus or minus the square root of b squared, 48 squared, 4 times negative 8 times 3, all over 2 times a, which is negative 8. Okay, so we have negative 48 plus or minus the square root. 48 squared plus 32 times 3. 2400. Okay, so plus or minus 2400. All over negative 16. Negative 48 plus or minus over negative 16 plus or minus 2400 over negative 16. Okay, so this is 3 plus or minus 2400. Well, 2400 is 24 times 100, so we have 10 square root 24 over negative 16 so far, but 24 breaks down to 6 and 4. And so that means this is 3 plus or minus the square root. Oops, plus or minus 24 is 4 times 6. Which means 2 times 10, which is 20. Square root 6 over negative 16. Which is 3 plus or minus, I don't know, 5, 4. 5 square root of 6, negative 4. So we want to know what time it hits the ground. So in this case, we have 3 plus negative 5 square root of 6 over 4. And 3 minus negative 5 square root 6 over 4. Which means we want to change that to plus. So we probably want this answer. I only know that because this is a negative. So if we subtract a negative, that adds. So that makes the distance further. I'm guessing this is around 3. So we'll use a calculator. We're going to do 5 times square root 6 divided by 4. We get 3.06. 6. Oops, that's ugly. 3.06. So 3 plus 3.06 is about 6.06 seconds. Okay, so that means it takes 6 seconds for the ball to hit the ground. Okay. So it's a little bit over 6 seconds, but we could have kind of estimated that. We know this is a parabola, so if we look at the symmetry of this, if it took 3 seconds to go this far, I mean, yeah, there's a little bit of room for it to hit down here, obviously, but if it took about 3 seconds to go there, it should take about 3 seconds to go there. That's how I kind of predicted it was going to be about 3. Finally, let's do the last one. It says, at what time will the ball reach 86 feet? Well, 86 feet is a height, so let's use the equation again. We want to know when it will hit 86 feet. Negative 16t squared. 96t plus 6 is equal to 86 feet. So let's go ahead and factor out. Actually, let's just subtract 86. We have negative 16t squared plus 96t minus 80 is equal to 0. I think 4 goes into all of these. We divide out actually, does 16? 16 goes into all of these, huh? Let's check. 96 divided by 16. Yeah, 80 divided by 16. Let's factor out it's negative 16. Negative 16 leaves us with t squared minus 6t plus 5 to 0. Just FOIL this back if you don't see it. It should equal the top one. And so if we do the factoring on that, this is 5 over negative 6. So we want negative 1, negative 5. This is t is equal to, oops, this means t, let me erase that real quick. This means t minus 1, t minus 5 is equal to 0. Oops, and then that tells us t is equal to 1 and t is equal to 5 at 1 second and 5 seconds. The ball is at 86 feet, and that makes sense, of course, because once we go back to the picture, 86 feet is probably like right here. This represents 1 second, this represents 5 seconds. And so, actually, it may be a little bit lower, but you get the point. It will hit it 2 times, once going up, once coming back down. And so I hope this is helpful, guys. Make sure you practice. I'm going to make one more video going through through a flow chart of what types of things you're going to see. I hope that you guys will try the next worksheet. It's a little bit challenging, but I think you guys can handle it. Thank you, guys.